determine whether the following series is convergent or divergent. So we got sum of -1 raised to n minus 1. This one pretty much gives us positive, negative sign. 7 raised to n all over 5 raised to n times n cubed. Okay, because of n cubed, we need n cubed and 5 to the n. We need to use the ratio test. Okay, if we only had like 7 raised to n and 5 raised to n, we could have used the root test, but here ratio test. So the whole thing is here, this one is an, and all we have to do is in the ratio test we take an plus 1 divided by an, take absolute value, makes everything positive, and we find the limit, and that should come out to be a number. And if this is bigger than 1, that means this series diverges. If this is less than 1, converges. If this is 1, then this test fails. We need to use another test. So here an is whatever this is, n minus 1, 7 raised to n all over 5 raised to n cubed, n plus 1. Just replace n by n plus 1. So this is -1 raised to n is now n plus 1 minus 1. N plus 1 minus 1. Just n. 7 raised to n is n plus 1 all over 5 raised to n plus 1 times n plus 1 cubed. Okay, an plus 1 is pretty much an with n replaced by n plus 1. Now we take the limit of absolute value of an plus 1 over an. Okay, that is limit n going to infinity of, when we take absolute value, all the terms will be positive. So this -1 to the n is producing negative, positive, -1, positive 1. So when we take absolute value, this is going to be always positive 1. And 1 times whatever this junk is, just that. So I don't have to even write this, and same thing here. So I'm not going to write absolute value. That will just take care of this -1 to the n and -1 to the n minus 1. So an plus 1 is this. So 7n plus 1 over 5n plus 1 times n plus 1 cubed. Okay, that's an plus 1 divided by an. Again, absolute value will take care of this sign. Just 7 to the n over 5 to the n cubed. Okay, so let's simplify this. So that limit is in fact limit n approaches to infinity. 7 raised to n plus 1 is same as 7 raised to n times 7 raised to 1. Okay, over same thing, 5 raised to n times 5, and we got n plus 1 cubed. That's on the top. Divided by means I'm going to change that division into multiplication. So I need to flip this fraction. So 5 to the n on the top, n cube on the top, all over 7 to the n on the bottom. Okay, so now we can cancel a couple of things here. 7 to the n cancel, 5 to the n cancel. What is left? Nothing more. Okay, so we are left with limit n approaches to infinity of 7n cube on the top, on the bottom 5 times n plus 1 cubed. Let me multiply out. Okay, I don't have to write everything because n plus 1 cubed is, we just multiply n plus 1, n plus 1, n plus 1 3 times, and it's gonna be at least we know the first term, very first term, because when we multiply this will be n cubed plus, I don't know, something else. Okay, 3n squared, but I don't have to know. And now I need to multiply by 5. So I'm going to write down 5 times n cubed plus 5 times just the other terms, because we are looking at limit at infinity, so only the leading term matters. So I just wrote the leading term. Okay, 5 n cubed. Now this limit is n cube same exponent, so 7 over 5. These terms do not matter because they are lower power terms, and when n is infinity they do not matter. Okay, just 7 over 5. Oh, that is bigger than 1. That means the series, the given series, diverges from the ratio test. Ratio test, the given series diverges, or the series is divergent, same thing.